Okay, welcome back. We're going to go through section 2.2 of chapter 2. It's higher derivatives. Okay, higher derivatives. So we are talking about, you should already know two derivatives. The first derivative is when you differentiate a function once. And the second derivative when you differentiate that derivative to obtain second derivative. You can actually carry on differentiating second derivative and third derivative to obtain the subsequent derivatives. So a little bit about notation. Okay, so you are familiar with the following notation. So if you've got the function y equals f of x, whatever it is, then when you differentiate once, you are finding dy dx. An alternative way of notating this is f dash of x. Now if you differentiate that again, you are going to get d2y dx squared, and then you put f double dash x. So these are the notations you are familiar. You can actually carry on with this vein. When you differentiate the second derivative, by the way, the action of differentiate the first derivative, you could actually write it d of dx, and then what you are differentiating you put in brackets. So in here it happens to be dy dx. So this is equal to d2y dx squared. So the next one here, if you do the same, you could do d dx of d2y dx squared. This tells you do the following, do this action, i.e. differentiate second derivative. You're going to obtain third derivative, d3y dx cubed, which is f. Now there are different thoughts on how you do the notation. The way I was taught, you use Roman numerals, and but I've seen also eventually going to normal Arabic digits, I guess. However, they put them in brackets. But the fourth one is like this, so I would put this notation. So that's perfectly sufficient. So this section simply prepares you for the next, what's to come next. So it's just practicing differentiating. So let's have a go at example 5 of chapter 2. So example 5 tells you to, given the function is y equals ln of 1 minus x, find the value of d3y dx cubed when x is equal to a half. So we're going to find what this is. Okay, so ln, remember y equals ln x. When you differentiate ln x, you are going to get 1 over x. That's what ln x differentiates to. So if you've got y equals to ln 1 minus x, then dy dx is going to be 1 over 1 minus x, but then you need to multiply by the derivative of the bracket, so it happens to be minus 1. You normally don't write this, you just put minus 1 straight in the numerator. Okay, now the next step is to differentiate this to obtain the next answer. Now it's better to actually get rid of that minus 1, or that's what I find it easier. So I'm just going to multiply the top and the bottom by minus 1. I will get x minus 1 on the bottom. So let's differentiate this function, d2y dx squared. So this here, if you rewrite it at x minus 1 to the power of minus 1, here we can use chain rule. a really quick chain rule. A linear bracket to the power of -1, you're going to differentiate it as if you were to differentiate x to the power of -1. So -1 comes down, the bracket is raised to power 1 less than -1, so take 1 off, and then you multiply it by what the bracket differentiates to. Here it happens to be 1, so really it's just not having an effect on the answer, so it's going to be minus x minus 1 to the power of -2. And then to obtain d3y dx cubed, we're going to do exactly the same. So let's keep that minus. Then we're going to bring the -2 down and multiply that by -1, because that is effectively -1. Reduce the power by 1, you get -3, and multiply by 1, which this bracket differentiates to, so leave it, so you get 2x minus 1 to the power of -3. So this is our third derivative. We are just asked to find the value of this when x is equal to 1/2. So we are going to obtain the answer of 2 times 1/2 minus 1 to the power of -3. You can pop it into the calculator, so it's going to be, but I'll do it with 2 over -1/2 cubed. So it gives you negative 2 over 1/8, which is 16 minus 16 is the answer. Okay, so we're going to move on to example 2 now. Okay, so here's example 2. F of x is equal to e to the power of x squared. Mr. Big, can you stop singing? Show that f dash of x is equal to 2x f of x. Okay, so that's simply asking you to differentiate this function. So if f of x is equal to e to the power of x squared, f dash of x, so we are going to use a chain rule. So e differentiates it to e to the power of x squared, and then you have to follow it by x squared differentiated, so 2x. Okay, so it's 2x e to the power of x squared, but e to the power of x squared is our f of x. So 2x f of x shown. There you go. For part B, the first part of part B, it's asking you to differentiate it again, the first derivative, so obtain second derivative, and then rewrite it in terms of f of x and f dash of x. So let's have a go at differentiating this function. We are going to use product rule. Let me just quickly remind you, it's always a good idea to quote it. It's uv differentiates to uv differentiates to, let's keep these outside, vu dash plus uv dash, but it doesn't matter with the product rule. You combine the derivative of one with the other, with one function with the second one unchanged, and then add it to the other way around, so as long as both are differentiated at some stage. So here we're going to use for u 2x and for v f of x. So u dash is going to be 2 and v dash is going to be f dash of x. We don't need to do anything else on that. So let's combine them in the right row. So v and u dash goes first, so that's going to be 2 f of x plus uv dash are these two, so 2x f dash of x, which is actually the result we wanted. Yeah, except I made a mistake, which is a good thing to always make mistake. It's nothing wrong with correcting yourself. For whatever reason, I differentiate f of x and wrote f dash double dash of x. So this is simply 2f of x plus 2x f dash of x. So by actually stating the product rule, I have shown this clearly. Okay, so the second part of part B again asks you to now differentiate my second derivative in order to obtain the third derivative. So let's just differentiate these as we go along. So we are going to differentiate 2f of x, bless you, 2f dash of x plus, and over here we're going to do another product rule for this part. Okay, so let's just do that. I don't need to quote it because I've already quoted it. So we're going to differentiate 2x f dash of x over here. So this is going to be my u, and this is going to be my v. Now I'm going to obtain f double dash x, and u dash is 2. So let's differentiate it. It's going to be vu dash. So I'm going to pop this. Actually, no, let's write it here. F dash of x first, and then plus 2x times f double dash of x. So let's copy this down onto this line. Let's change the color to black. Okay, so we are going to get 2f dash of x plus 2x f double dash of x. Altogether, we're going to obtain 4f dash of x and then 2x f double dash of x. Let's write it in the order that they've asked us to write it in. So as asked, as required. Okay, and for the final part, you've been asked to find the values of the f of 0, f dash of 0, and etc. all the way up to f triple dash of 0. So part C, f of 0, let's substitute it e to the power of 0 squared. That's going to be 1. F dash of 0, so that's going to be 2 times 0 times f of 0, which doesn't matter that it's 1 because the 0 just changes it all to 0. F double dash of 0, this one is 2 times f of 0 plus 2 times 0 times f dash of 0. This is 0. F of 0 is 1, so it's 2 times 1, which is 2. F triple 0, which is 2 times 0 times f double dash of 0, so that just goes to 0, plus 4, first derivative evaluated at 0, so this is going to be 4 times 2, which gives me 8. No, I've looked at the second derivative. It's actually going to be 4 times 0, which is 0. So we've got, let me just underline those answers clearly. You've got the first value we found was 1, that was f of 0. The second value found was 0, that's f dash of 0. This third one is 2, and the last one is 0. So now you're ready to have a go at exercise 2b. If you haven't had a look at this video before learning about differentiation, I'll be making another video that will cover all the methods you will need to master in order to succeed in this part of the chapter. Okay, thank you.